Okay, we are unpacking an absolutely massive leap in artificial intelligence today. Seriously, this one is big. We're looking at a brand new paper from the team over at GPU AI and Tsinghua University detailing their new model, GLM-5. Now, right off the bat, you should know this isn't just your standard, everyday incremental update. We are talking about a fundamental shift in how large language models actually interact with the digital world, specifically in the realm of software development and long-term problem solving. If you've been following the frontier of AI, you know we've been waiting for a model that can truly act independently over long periods. Well, GLM-5 might just be the engine that gets us there.
So let's dive right into the core thesis here, straight from the paper itself. The authors clearly state their goal is to, quote, transition the paradigm of vibe coding to agentic engineering. Now, what exactly does that mean? Well, vibe coding is essentially what most of us are doing right now, right? You write a prompt, the AI spits out a snippet of code, you paste it into your editor, it inevitably breaks, you copy the error, paste it back in, and you just kind of brute force your way to a working solution. It's a very passive, highly supervised loop. GLM-5 is built to completely break that cycle and move us into active, autonomous generation.
And that leads us to this concept of agentic engineering. In practical terms, this means the AI becomes an active, autonomous problem solver. It's not just writing a single function anymore. It's actually looking at an entire, complex, multi-file codebase. It understands the overarching architecture, plans out a whole sequence of changes, executes them, and, this is the kicker, fixes its own errors, all over a really long time horizon. In the past, the two massive bottlenecks stopping this were computational cost, because, keeping all that context in memory is crazy expensive, and real-world adaptability. I mean, static benchmarks are one thing, but a messy real-world software repository, that's a whole different beast. But GLM-5 was built from the ground up to conquer both.
Dominating the AI leaderboards, setting new standards. Let's look at the numbers.
Because while the underlying architecture is super fascinating, the actual results are what prove GLM-5's dominance. Take a look at the Artificial Analysis Intelligence Index v4.0. This index is no joke. It aggregates 10 different evaluations spanning reasoning, coding, and knowledge benchmarks. And right now, GLM-5 is the new open weights leader, meaning yes, anyone can download and use its core engine. It pulled off an incredible 8-point jump from its predecessor, GLM-4.7, and it just rocketed past other models to legitimately rival proprietary closed-source giants like Claude Opus 4.5 and GPT-5.2.
I really want to punch up this specific number for a second. 50. It scored a 50 on the intelligence index. This is a massive milestone. Why? Because it marks the very first time in history that an open weights model has achieved a score of 50 or higher on this specific, highly rigorous index. It's a huge testament to the fact that open-source AI is no longer just trailing behind the closed models. It is actively setting the pace.
But, static benchmarks only tell part of the story, right? Let's talk about Ella Marina. This is a transparent evaluation space run by UC Berkeley where models are judged blind by millions of real human interactions. And here, GLM-5 absolutely dominates. It's the #1 open model in the text arena, and even more importantly for what we're talking about today, the #1 open model in the code arena. This proves its agentic capabilities aren't just some theoretical lab trick. They have tangible, real-world utility that human developers genuinely prefer.
Mastering long horizon tasks, the endurance test. Let's see how it holds up over time.
Because if standard coding is a sprint, agentic engineering is a full-on marathon. It's one thing for an AI to quickly write a Python script in 30 seconds. It is an entirely different beast for it to maintain coherence, manage resources, and plan dynamically over a really long time frame. To truly test this, the researchers didn't just ask the AI to write more code, they actually asked it to run an entire simulated business.
To test this endurance, they used something called Vending Bench 2. Here, the model is tasked with running a simulated vending machine business over the course of a full year. It literally has to manage inventory, track the finances, and adapt to changing market conditions day after day after day. And GLM-5 absolutely crushed it. It finished the simulated year with a massive final account balance of $4,432. It ranks #1 among all open models for this, and it's rapidly approaching the performance of Claude Opus 4.5. The sheer endurance and long-term memory required to pull that off is just staggering. So how does it do it? The engine, Deep-Seek Sparse Attention, or DSA. This is exactly how GLM-5 manages its massive 744 billion parameter structure without completely breaking the computational bank. The secret sauce here lies in how the model actually pays attention. Traditional dense attention mechanisms have what's called a quadratic cost. That basically means as the text gets longer, the computational cost explodes exponentially. It's just not sustainable. Instead, GLM-5 utilizes DSA. You can think of DSA like a highly dynamic spotlight. Instead of forcing the AI to look at every single word in a 100,000-word document equally, DSA uses an indexer to quickly retrieve only the most important relevant tokens. It drastically lowers the overhead, but it doesn't lose the deep reasoning required for those complex tasks.
And crucially, making the attention sparse doesn't make the model any dumber. Look at this comparison. When matched against a dense, multi-latent attention model, or MLA, the DSA model maintains a perfect 100% on needle-in-a-haystack tasks. That means it can flawlessly recall a single, highly specific fact hidden inside a massive document. It actually even beats the dense model on the Squad 128K benchmark, scoring an 86 compared to 79.7. So it retains all the fidelity, all the smarts, but entirely avoids the astronomical cost of dense training. It's brilliant.
Because this DSA architecture is so insanely efficient, the team was able to push the model's memory limits through a really clever progressive mid-training phase. They didn't just dump a massive textbook into its digital brain all at once. They stepped it up gradually. They started with 4,000 tokens during general pre-training. Then they moved to 32K, then 128K, and finally they explicitly fed it 50 billion tokens of long-context agentic data to stretch its working window to an incredible 200,000 tokens. Put simply, for a developer, this means you can literally drop your entire app source code into the prompt all at once, and the AI can hold the whole shebang in its working memory.
Training autonomous intelligence, the secret sauce. Let's look at the final training steps.
Okay, so now that we have this massive-brained, highly efficient model, we have to actually teach it autonomy. This happens in the post-training pipeline. After supervised fine-tuning, the model goes through a sequential reinforcement learning pipeline. But there's a huge risk here. Typically, when you teach a model to be an autonomous agent, it often forgets how to be a good general reasoner. It's a well-known problem called catastrophic forgetting. To solve this, the team implemented something called on-policy cross-stage distillation. This is crucial because it ensures the model retains its sharp foundational reasoning edge even as it transforms into a highly specialized coding agent.
This reinforcement learning itself is broken down into 3 distinct steps. First, you have reasoning RL, which focuses heavily on math, science, and competitive code. Second is the agentic RL. And third, general RL, to ensure proper human-style alignment. What is really amazing about that middle step, the agentic RL phase, is that they completely decoupled the inference engines from the training engines. You see, because agent rollouts take a long time, like simulating that business for a year, a normal training GPU would just sit there idle, waiting for the final result. By decoupling them, they maximized GPU utilization, which allowed for this massive-scale exploration of different agent trajectories. And this rigorous training fundamentally changes the way GLM-5 actually processes information. When interacting over multiple turns, the AI is no longer just predicting the next word blindly. It has developed very specific thinking modes. It literally learns to pause, generate a dedicated thinking block to reason about the problem, call a tool, review that tool's result, and only then formulate its final answer to you.
This results in 3 really advanced thinking characteristics that make GLM-5 such a powerhouse. First is interleave thinking, meaning it pauses to think before every single tool call or response. This ensures it doesn't make rash actions. Second is preserve thinking. In a long coding session, it automatically retains its previous thinking blocks across turns. It doesn't have to rederive its own logic from scratch every single time you ask a follow-up question. It actually remembers its own internal monologue. And finally, turn-level thinking. This means it can dynamically turn this deep reasoning on or off depending on whether the task actually requires it, which saves tons of time and compute on simpler requests. Wow, we have covered a staggering amount of innovation today. From the raw efficiency of DeepSeek's sparse attention to those massive 200,000 token context windows, right down to the asynchronous reinforcement learning that gives this model true autonomy. GLM-5 has firmly shifted the paradigm from passive vibe coding to active agentic engineering. Which really leaves us with a profound question to think about. What happens to the entire software industry, and honestly the global race toward artificial general intelligence, now that an open source model available for anyone to just download and use can autonomously engineer complex code and successfully manage a simulated business for an entire year? It's a whole new world out there. Thanks so much for joining me on this explainer, and as always, keep exploring.